Alright, hello. We are on to Chapter 7, you guys. We have 3 more weeks left. 4 lessons, and last week will just be a review and a performance task. This is it. I'm super proud of all of you guys. Really, really proud of all the obstacles you guys have overcome this year. It's awesome. Rational functions, expressions, we're going to graph, we're going to simplify, we're going to solve, and basically all this just is in relation to polynomials. So, here we go, guys. Chapter 7, Rational Functions, 7.2, Graphing Rational Functions. First of all, what's a rational function? Well, a rational function is a function in the form of f of x equals p of x over q of x, and where your p of x and q of x are polynomials. Alright, so we have fractions with polynomials. This is pretty important, actually. Q of x cannot be 0, because then can't have 0 in your denominator, and that would be undefined, and we're going to continuously come back to that. Alright, this next part right here is describing the parent functions of simple rational functions, and parent function is the most basic function, and that's where f of x equals 1 over x. This is a hyperbola that has symmetrical parts, so you can see it kind of mirrors right there. We are going to have domain and range with these, and for our parent function, they're going to be all real numbers. And we are going to have asymptotes, and that's where it approaches a line, but it does not touch. Alright, so if you look here, here is the graphed parent function. I went ahead and put our table up here. So our function, f of x equals 1 over x, and I just chose negative 3, negative 2, negative 1, 1, 2, and 3. I can't choose 0 because if I do 1 over 0, again, that's undefined, so that is where our vertical asymptote is. Alright, so plug in negative 3. 1 over negative 3, I get negative 1/3. Plug in negative 2, I get 1 over negative 2, negative 1/2. Plug in negative 1, 1 over negative 1, I get negative 1. Plug in 1, 1 over 1 is 1. Plug in 2, 1 over 2 is 1/2. Plug in 3, 1 over 3 is 1/3. Graphed them right there, and voila, there is our parent function. Okay, so we are going to manipulate that here and there. We are going to start with this concept 1, where we're going to graph a rational function in basically this same form, y equals a over x. Alright, and therefore our asymptotes is going to be x equals 0 and y equals 0, just like that, because we can't have 0 in our denominator there. And I already chose the points into the table. You guys can pause it and write that there if you like. And I'm just going to keep on going. So here we go. I'm going to plug in negative 3 in for x. I get 4 over 3, and that is negative 4/3. Plug in negative 2, I get 4 over negative 2, and that is negative 2. Plug in negative 1, 4 over negative 1 is negative 4. Plug in 1, 4 over 1 is 4, 4 over 2 is 2, 4 over 3 is 4/3. Awesome. Okay, so I'm going to do a couple things here. So I am going to go ahead and dash our asymptotes, just kind of like, well, they didn't do it there, actually. But I'm going to do it just so you can kind of see what goes on here. We kind of dash those asymptotes so we know that it approaches those dash lines, but it doesn't actually touch. Okay. Alright, I am going to go ahead and plot these points. So negative 3, negative 4/3. That is 3 to the left of my origin. 1, 2, 3. And then down a little past negative 1. Negative 2, 2 left, down 2. Negative 1, negative 4, 1 to the left, down 1, 2, 3, 4, and voila, we have 3 points. I could do more, but 3 is really the minimum. And I'm going to just draw a line, and again, it's going to approach that dash line. It's going to curve, and again, approach that dash line, and there is half of the graph. Other half, 1, 4. So I started my origin, I go 1 to the right, I go up 1, 2, 3, 4, 2, 2. 2 to the right, up 2, and 3 to the right, up 4/3, a little past the 1, and I'm going to swoop down, and again approach that dash line right there. And voila, we have done it. There is our graph of this rational function, g of x equals 4 over x. The second part that you're going to be asked for is maybe compare the graph to its parent function. Well, if I look back up here, the way I'd do that would be is, look, negative 1, 1 is right there, 1, 1 is right there, and maybe I just plot those points right here and right here, and what can I tell about my curve line compared to those dots? Not much, except that they're farther from our axes, and that's really all you want to say. Okay, so I'm going to write it. The graph of G lies farther from the axes than the parent function, or than the graph of f. Okay. Alright guys, there's the first part. Go ahead and pause it, give it a try. I am going to just scoot it down right now and show the answer for number 2. And here you go. There it is. Hopefully you got that. It makes some sense. I'm going to go ahead and flip it up here. And concept 2. All right, we're going to graph translations of simple radical form. So here is the form. It's going to switch a little bit than what we had, the y equals a over x, to now y equals a over x minus h, and then plus k. Well, h and k. H is a horizontal shift, right or left. K is a vertical shift up or down. So those are the translations we're talking about. We got 3 steps. We are going to draw an asymptote, and then your new asymptotes are not going to be your axes. It's going to be the x is going to equal your h, and the y is equal to your k. Basically, we're going to plot points to the left and right of those asymptotes. I'd say 3 to the left, 3 to the right is our bare minimum, which is all you need. And then draw your lines, make some hyperbolas, and there you go. Okay, so here we are. Concept 2. It says graph g of x equals negative 4 over x plus 2 minus 1, and then state the domain and range. And I kind of already started, so just to kind of get us moving, what is x? Well, x equals h, and if you look at that form, it's minus h, right? And I got plus 2 there, so it's really negative 2. Alright, and I'm just going to go ahead and dash x equals negative 2. I move to the left, right there. And then I have k, and it's plus k, and I have negative 1, so that is going to be negative 1. So y is negative 1, and there is my, or are my asymptotes. Next part, let's go ahead and put some points in. And I apologize, in doing this, I put the first one. So here we go. We're going to choose negative 6. So again, negative 2 is not going to work. I can't plug in negative 2. That is, again, your asymptote, so it's not going to work here. It will also give us undefined, or 0 in our denominator. Alright, so here we go. Negative 4 over negative 6 plus 2, which is negative 4. Negative 4 over negative 4 is 1, minus 1 is 0. Plug in maybe 4, all right, or negative 4 in this case. So here, negative 4 plus 2 is negative 2. Negative 4 over negative 2 is positive 2. Minus 1 is 1. Plug in negative 3. Now I have negative 3 plus 2 is negative 1. Negative 4 over negative 1 is positive 4. Minus 1 is 3. Plug in negative 1. Again, I can't choose negative 2. So negative 1. That gives me negative 1 and 2 is positive 1. Negative 4 over positive 1 is negative 4. Minus 1 is negative 5. Plug in 0. That gives me 4 over negative 4 over positive 2, which is negative 2, minus 1 is negative 3. And the last but not least, I'm going to choose 2. 2 plus 2 is 4. Negative 4 over 4 is negative 1, minus 1 is negative 2. Alright, so I am going to go ahead and plot those points. I'm just going to use a different color here. Negative 6, so I go 6, 1, 2, 3, 4, 5, 6, 0 right there. Negative 4 right there, and up 1. Negative 3, 3, up 1, 2, 3. There we go. And there's our first branch. Second, I drew negative 1, negative 5. So 1 to the left down, 1, 2, 3, 4, 5. 0 down 3, 1, 2, 3. And 2 to the right down, 1, 2 right there. Draw that. And it looks like so. Alright. Excellent. We have graphed our rational function. Our next part, in this case, is state the domain and range. And it's going to be really similar. Domain is going to be all the real numbers except the asymptote right there. So it's going to be all real numbers except where x equals negative 2. So it's going to be negative 2. Range is going to be all real numbers except negative 1, or y would be for your asymptotes. Okay. Hopefully that wasn't too quick. That is the plan there for concept 2. Go ahead and pause it. Give number 4 a try. I am going to scoot it on down. Okay, there is your answer to number 4. And voila. Alright. So I am going to go ahead and explain this before I flip, and I'm probably going to have to stop this video. But anyway, graphing other rational functions. We have another type of form. Y equals ax plus b over cx plus d. And our vertical asymptote, where x is going to be negative d over c, and I'm going to show that real quick to the side here. All I'm really doing is cx plus d, the denominator, set it equal to 0, subtract d right there, I get cx equals negative d, divided by c, and now I get x equals negative d over c, which is what we have right there. Okay, so if you just want to set it equal to 0 and solve, that will work. And then our other part, your horizontal asymptote, y is equal to a over c, and that's really this a and that c right there. So it's really just those two parts right there. Alright, I'm going to go ahead and flip to page 3 and stop this video.